want to thank Jim Emery for inviting me to do this. I really appreciate it, Jim. And I'm going to jump right in. Going to jump right in by reading these three statements. There's an overwhelming international scientific consensus on the following 3 points. Number one, over the past 120 years, the Earth has been warming and the climate has been changing at alarming rates. Number two, the global warming and resulting climate change of the past 120 years have been driven almost exclusively by the accumulation of greenhouse gases in the atmosphere caused by human activities. And finally, without dramatic reduction in the emission of greenhouse gases into the atmosphere, the Earth will continue to warm and the climate will continue to change to the detriment of humankind. Stated succinctly, it's number one, it's happening. Number two, humans are causing it. And number three, it's not a good thing. Now, not just me saying this, pretty much all the leading science organizations in the world have made formal declarations confirming human-induced global warming. And this is just a partial list of those organizations, including all the most prestigious science organizations in the United States. So let's look a little bit into the science of global warming and climate change. And I like to approach it from the long-term view. So what we're looking at here is a graph of global mean surface temperature of the Earth over the past 22,000 years. So 22,000 years ago, up to the present, I should say. Now, and by the way, if everyone would mute their microphones, sorry I forgot to say that, but it's helpful for everyone to mute your microphones. If you have a question, unmute and get my attention, but we're going to have hopefully plenty of time for a question and answer and discussion afterwards. Now, global mean implies averaged over the entire face of the Earth. Surface temperature is the sea surface temperature over the ocean. It's a temperature a few meters above the ground over the land. And what we see here are a couple identifiable things. This is the end of the last ice age, this cool period right here. This is the approximate beginning of human civilization, about 9,000 years ago. This is called the Holocene warm or interglacial period. And moving on, this of course is the recovery from the last ice age, and it was driven by what's called the eccentricity cycle of the Earth's orbit around the sun. What happens here is the Earth's orbit varies on a 100,000-year cycle from being drawn out more like an ellipse and less drawn out more like a circle. This is exaggerated, but that's the basic idea. And when the Earth draws out more like an ellipse, that causes us to go into an ice age. When it comes back the other way, more like a circle, that brings us out of the ice age. It takes about 10,000 years to do that. And then we see this slow cooling trend over about the last 7,000 years. That's actually been driven by what's called the obliquity cycle. I'm sure you all know the Earth's axis is inclined relative to the plane in which it orbits, but you may not know that it rocks back and forth. That's due to the effect of the gravity of the sun and the moon on the Earth. This is caused by the gravity of Jupiter and Saturn on the Earth. Right now, we're about halfway through this cycle and losing tilt. And that loss of tilt is driving the slow cooling trend here that we've experienced for the past 7,000 years. A couple of other identifiable features. This is called the Younger Dryas period, an interruption in the warming from the last ice age. This is called the Medieval Warm period. It was about from 900 to 1200 AD. And this is the so-called Little Ice Age. It took place from about 1500 to 1700 AD. And finally, we see this red spike. This red spike is in fact the post-industrial global warming we are concerned with. Now, there are a couple things that are immediately apparent when you look at this from this viewpoint. First of all, the global warming we're concerned about is going in the wrong direction. The Earth should be cooling. In fact, under normal circumstances, it would cool for another 8,000 years or so, then turn down cooling even faster for another 10,000 years, and we'd be in the next ice age. But instead, we're going in the wrong direction. We're going opposite to natural climate change. And in fact, we're going really fast. The rate at which the Earth has been warming for the past 120 years is about 20 times faster than normal climate change. So global warming in the past 120 years is proceeding about 20 times faster and in the opposite direction of natural climate change. And oh, by the way, its onset occurs exactly at the beginning of the industrial age, when humans began emitting large amounts of CO2 into the atmosphere. So what's going on here? Well, of course, it's the greenhouse effect, and I'm sure you're all pretty familiar with that. It's pretty straightforward. Basically, the Earth is warmed by the sun, and it's cooled by reflected solar radiation and outgoing long-wave radiation, also known as infrared radiation. And the greenhouse gases in the atmosphere trap the outgoing long-wave radiation and increase the warming. Here are the greenhouse gases in order of how much infrared radiation they trap. That's water vapor, carbon dioxide, methane. The F gases are fluorinated gases, and nitrous oxide. And finally, human activities increase the greenhouse gases in the atmosphere and increase the warming. Notice I've colored water vapor differently, and that's because water vapor is not being increased by human activities. It's not really driving global warming, but it is participating in global warming, as you'll see in a minute. The four gases colored in magenta here are the long-lived anthropogenic greenhouse gases. These are the ones that are really driving climate change, and CO2 is the dominant greenhouse gas. Now, in addition to this effect, there are feedback effects that come into play that are very important. And there are two in particular that amplify the warming. The first is called the snow ice feedback effect. And it works like this. Increasing global temperatures produce decreasing snow and ice. You can see that here, for example, sea ice melting in the Arctic. And that increases the sunlight absorbed by land and sea, because when the ice melts, what's left behind is a much darker scene, and that absorbs more solar radiation. And of course, that makes the temperature go up even faster, and you keep going around this feedback loop, and that amplifies the warming. The second important feedback loop is the water vapor feedback loop. As global temperatures are increasing, this increases evaporation of water from oceans and land. As the ocean warms up, there's more evaporation occurring. Also, as the atmosphere gets warmer, it can hold more water. So there's more and more water vapor going in or being retained in the atmosphere. In other words, the atmosphere is progressively getting more humid. This increasing water vapor in the atmosphere, or increasing humidity, because water vapor is a powerful greenhouse gas, traps more heat. That increases the global temperatures more, and you go around this feedback loop and amplify the warming. And in fact, these two feedback loops, the snow ice feedback and the water vapor feedback, have amplified the warming we've experienced since the industrial era by about a factor of 3. So very powerful effects there. Fortunately, there's also a negative feedback, and it works like this. As the Earth warms up, it radiates more long-wave radiation away. In fact, it goes out it is radiated in proportion to the temperature of the Earth to the 4th power, where temperature is measured on the absolute temperature scale. And this is a negative feedback loop, because as the increasing global temperatures occur, this increases the outgoing long-wave radiation and surface cooling, which tries to decrease surface temperatures. So as the Earth warms up, this effect, this outgoing long-wave radiative feedback effect, tries to cool the Earth back down. And it's a good thing it does, because if we didn't have this negative feedback effect, we would currently be warming about 3 times faster than we are. And we would currently, rather than being 1.2 degrees centigrade above the pre-industrial level, we'd now be probably around 3.5 degrees above the pre-industrial level, and worrying about going to 9 degrees or more by the end of the century. So here's where we are right now, about 1.2 degrees above the pre-industrial level. Where are we going? Well, if the world follows all the recommendations, the most stringent recommendations of the Paris Climate Accord, which means we would achieve net zero greenhouse gas emissions by 2050. Now, net zero means we're putting greenhouse gases into the atmosphere at the same rate the natural world is able to take them out. If we were able to achieve that, then we would be able to hold warming to 1.5 degrees C, plus or minus 0.7 above pre-industrial by the end of this century, by 2100. On the other hand, if we completely ignore the Paris Accord and throw our hands up and give up on this, and just keep burning fossil fuels with abandon, then we're going way up here, and that's 4.5 degrees C, plus or minus 1 degree C above pre-industrial. Look how extreme that would be. It's the difference between an ice age and a warm period. Well, fortunately, we're not going up there. We're doing a lot better than that, but not that much better. Here's where we're on track for right now. The UN Environment Program issues annual emissions gap reports. You can think of that as being like a report card on how well the world is doing in achieving the goals of the Paris Accord. The latest one came out this past fall, and it basically said, we've been falling behind. Every report that's come out since the Paris Accord has shown we're falling farther and farther behind. The report that came out this past fall said we're on track for 3 degrees C of warming right now. Well, I think we're going to do a little bit better. I'm a little bit more optimistic. Here's my personal prediction where I think we're going to end up by the end of this century, and that would be 2.5 C above pre-industrial. Now we can all agree to meet back here in 79 years if you want to do that, another Zoom meeting, and we can see if I'm right or not. A lot of my colleagues think I'm being overly optimistic here. Some are thinking, it's actually going to be much worse than this. I'm a little bit optimistic here because mainly because the U.S. has rejoined the Paris Accord. You might have seen in the news today that President Biden announced some very aggressive targets and what we want to achieve in the U.S. And that's going to inspire the rest of the world. Canada's already come forward and said, okay, in light of what the U.S. is saying, we're going to up our goals too. So I'm a little bit optimistic here. So finally, just 2 more slides. I want to talk about what the consequences are of what's going on here. And these are the trends that are happening now, they're observed now, that we expect to continue and even get worse into the future. I'll just hit the highlights. Increasing frequency and intensity of severe storms. And that would be both summertime storms like hurricanes, but also wintertime storms like blizzards, like the storm that caused all the problems down in Texas. Increasing frequency of light-threatening heat waves. Increasing frequency and intensity of floods in normally wet regions, increasing frequency of droughts and wildfires in normally dry regions like where we live, decreasing mountain snowpacks and earlier snow melt, big problem in California since we get a lot of our water from the Sierra snowpack, rising sea levels, increasing mortality of coral reefs, coral bleaching, decreasing productivity of fisheries, and increasing species migrations and extinctions with loss of biodiversity. So that's the impacts on the natural world. Now let's think about the impacts on the human world. And that would be increasing economic cost resulting from increasing frequency and intensity of damaging weather events, increasing prevalence of wildfires and rising sea levels, increasing competition among nations for water and food caused by increasing drought and decreasing agricultural and fisheries production, increasing displacements of people caused by increasing drought, floods, extreme weather, and sea level rise, leading to unrest in populations susceptible to recruitment by violent extremist groups. Increasing threats to human health as tropical diseases spread into the higher latitudes and reduced biodiversity increases the likelihood that diseases will jump from animals to humans. Increasing mortality from heat waves, other severe weather events, starvation, disease, and war. And finally, I'll point out that these risks are unevenly distributed between groups of people, between regions, between nations. Risks are generally greater for disadvantaged people living on the edge in developing countries. And there are many, many people in the world who are living on the edge. They're living with insecurity of food, water, and living space. And climate change will hit them the hardest. So that's it. Now I'm going to stop the sharing, go back to, I'm going to go back to speaker view here and open up to questions and discussion. Jim, I think you're muted if you want to unmute yourself there.
One comment I'd like to make, if the variations from natural causes, like tip of the earth and so on, are often ignored by deniers. They say, look we've had weather change for as far as we can look back. Therefore, we don't have anything to worry about because this is just another natural change. The fact is, we know very precisely why we've had the past variation, and it had nothing to do with CO2 emission by humans. It was totally natural. So the deniers cannot use past weather as proof that variation is perfectly natural.
Yeah, I didn't show the chart today, but I have a graph that goes back 5 million years. I showed the one that goes back 22,000 years. And when you show the one that goes back 5 million years, you really see the ice age cycle. We've actually gone through dozens and dozens of ice ages if you go back 5 million years. And Jim is quite right. It certainly wasn't caused by humans. It was natural variability, but we understand it. In fact, we've understood the ice age cycle for about 120 years. There's a gentleman by the name of Milutin Milankovic. He was a Serbian astronomer and geophysicist, and he's the one that figured that out, published his paper back in 1920. So we've understood all that since about the 1920s. Next question.
Go ahead.
Last night Nova had a special on the coral bleaching. I'm about a third of the way through it before our class today.
Yeah.
And they link it to El Nino, but I've never heard El Nino linked to human carbon use or coal and all that. So is there a link between El Nino and?
Well, the real link to coral bleaching in El Nino is the fact that it's warmer temperatures. There's two things that kill coral reefs and causes coral bleaching effect. One is warming temperature, and they often you hear the term ocean heat waves, where the water comes in, it's much warmer than normal, and the polyps and the corals can only survive in a pretty narrow range of temperature. So you get this warm water coming in, and that can cause them to die, and they expel the zooxanthellae, and as a result, you get this white effect. And it looks like it's been bleached. The other thing is ocean acidification. As more and more CO2 is being put in the atmosphere, the CO2 in the ocean is actually going up because there's so much in the air above. And that ocean acidification makes it difficult for the larvae of shellfish, including the coral polyps, to form their shells. And as a result, that's contributing to coral bleaching. Now, the effect of El Nino is El Nino is an outbreak of warm water along the equator, which happens semi-periodically, typically about every 6 or 7 years. So if you've got the ocean warming because of climate change, and then on top of that you throw in an El Nino, then you're really stressing the coral out, because you're really taking them to a higher temperature that they can't survive, and that's how you get the coral bleaching. But I don't think there's any evidence to indicate that El Nino is happening more frequently as a result of climate change. El Nino falls into, I didn't show the graph today, but I know Jim has seen it and others may have seen it. Sort of three broad classes of variability in the atmosphere. There's weather, there's climate variability, and there's climate change. El Nino falls in that middle category of climate variability. And that's variability that occurs on scales of months to a couple of decades, on scales of about Pacific Ocean basin size. And distinctly different from climate change. Climate change is happening on timescales of 30 years or longer, and it's a global phenomenon. So you'll look at the temperature going up, and you'll see these zigs and zags. Those zigs and zags are things like El Nino. They can cause a temporary decline in temperature, even though the long-term trend is upward. Looks like Lois has a question, or Lois.
About the other nations, China in particular. Mm-hmm. What's your thought on how are they going to be compliant with climate change? I saw their coal was burning even more. Coal combustion's greater this year.
Yeah, I'm really glad you brought up China. China is a complicated question, a complicated issue. It's a mixed bag. First of all, China is the world's largest emitter of CO2 by a wide margin. We're number 2, but we're down pretty far compared to China. On the other hand, if you look at per capita emissions, China then falls pretty far down the list. Their per capita emissions are actually about half of our per capita emissions. There's a lot of people in China, and we're number 1 in terms of per capita emissions. So here's the thing about China, why I say mixed bag. China is leading the world by far in bringing on green energy. They're leading the world in bringing on solar. They're leading the world in bringing on wind, but they're also leading the world in bringing on coal-fired power plants, which are the dirtiest burning power plants. The bottom line is China is extremely energy hungry, and you can kind of get that when you look at how low their per capita emissions are. They have so many people. They're trying to increase their standard of living. Xi Jinping wants to stay in power, and the way to do that is increase the standard of living of his people. The way to do that is to make energy more available. So they're just extremely energy hungry, and yes, they are in leading in green energy, but they're also leading in coal-powered, which are the dirtiest burning power plants. Now, in terms of the Paris Accord, yes, they are honoring their commitments, but their commitments, let me back up and talk about the Paris Accord. There was, prior to the Paris Accord, there was something called the Kyoto Protocol, and that happened back in the 90s. And the Kyoto Protocol was very aggressive. It had teeth. It actually assigned emissions targets to every country, and it had teeth in the sense that if each country didn't meet that target, there were penalties that were applied. Unfortunately, the Kyoto Protocol fell apart pretty fast, and to a great extent, that was driven by the fact the United States never ratified the treaty. President Clinton negotiated, where actually John Kerry, actually Al Gore negotiated and signed the treaty, but President Clinton was unable to get it ratified through the Senate. And when George W. Bush came in, he dropped the Kyoto Protocol, never pursued it. When that happened, pretty quickly after that, it fell apart. The Paris Accord, on the other hand, doesn't have the teeth of the Kyoto Protocol, and it's pretty much a voluntary thing. It's like each country comes to the table and says, okay, here's our national plan, and we agree to meet it. That's pretty much what the Paris Accord is. But every country had the option of defining their own national plan. Now, every country has been falling behind their own national plan. Most of the national plans were pretty good, and every country has kind of been falling behind. Certainly, the U.S. has been, because we pulled out of the accord. And that's why we're on track for 3 degrees of warming, like I showed, rather than 1.5 degrees of warming. Well, China came forward and said, our plan is we're going to keep increasing burning of fossil fuels, but we're going to peak at 2030, and then we're going to go down. But you got to let us keep on growing to 2030 because, we're a developing country. We need this energy. We've got to keep on growing. So while we're trying to come down, they're still going up, and their pledge is to peak in 2030 and come down and get to where they need to be later, in the century. And of course, a lot of people have objected to that, but that's where we're at.
David Barish, and you're muted.
Mute me. What about Russia? Russia has a lot of land that would become more habitable if the climate got warmer. So what's the Russian position on this issue?
Well, Russia is the world's largest developer or producer of oil, and that's it's a linchpin of their economy. So you would think Russia would be pretty negative on this, but on the other hand, there was this virtual climate summit going on today and the rest of this week, and that's the thing that I mentioned earlier, that President Biden made some statements and some commitments on that. Well, Putin was involved in that. Putin was right there, and he said, we're going to meet our Paris Accord goals. So that's a good thing. On the other hand, Putin wants to start doing more drilling in the Arctic, which is not necessarily a good thing. Russia, the big problem, one of the big problems, and I'll go back a little bit to the science, I talked about those positive feedback effects, and I talked about the water vapor feedback effect and the snow ice feedback effect. You may have heard the term tipping point. Tipping point. What's a tipping point? Well, a tipping point is just a positive feedback that's going to accelerate the warming that hasn't kicked in yet. You have to get a little bit warmer to cross some threshold, and all of a sudden suddenly you activate another positive feedback effect, which can amplify the warming. Well, the tipping point that is of greatest concern is the permafrost and methane tipping point. And that is if the Earth gets to a certain level of warming, and the one figure I've seen on that is about 5 degrees C above pre-industrial, but I'm not sure we know that well. If it gets to somewhere in that range, then enough of the permafrost melts in Siberia, in Russia, but also in northern Canada, that suddenly you start releasing a lot of methane into the atmosphere. There's a huge amount of carbon that's captured in the permafrost in Siberia, in Russia, and Canada. And it's like more carbon there than all the trees on the Earth, more carbon there than exists in the atmosphere currently. And that carbon decay, or that plant life there, prehistoric plant life, and decays in the absence of oxygen, it forms methane. And so if you go up in Siberia and the permafrost, you'll clear off the snow there, look at the ground, it's like frozen ground. You'll see bubbles down there. If you puncture the permafrost with your ice axe, the gas will flow out, and you light a match to it, it'll ignite. It's methane. And methane is has a global warming potential of 28, which means if you emit 1 ton of methane into the atmosphere, it's going to have 28 times the impact of 1 ton of CO2 over the next 100 years. So Russia has, they have a big potential part of the problem right in their backyard, and because they've got a huge amount of this permafrost there. So I'm sure they're trying to balance it out. You know, they want to sustain their economy. They want to continue exporting oil, but at the same time, they must be sensitive to the fact that, you know, they have this huge amount of methane in their backyard.
Ron, and you're muted.
Good morning.
Hi.
The release of or escape of nuclear waste into the ocean, does that contribute to the warming just on a local level, or is it more widespread?
Well, you're probably referring to Fukushima. What's happening there at Fukushima? You know, from the time they had that problem, that you know, catastrophic failure, they've had to be cooling. They've had to continue trying to cool the reactor. And the way they've done that is circulating water through there. And as the water circulates through the damaged reactors, it picks up radioactivity. So they've been putting it into these holding tanks, and maybe it's a reservoir or a lake or something there, Fukushima Prefecture. Well, they're running out of storage, and so they're soon going to come to the point where they start releasing that radioactive water into the ocean. That's a big issue in Japan. Of course, you know, environmentalists are trying to stop that, but it looks like the government, I think I read recently, the government said they're going to have to go ahead and do that. The water is not actually warm. It's you know, it's not like it's really hot or anything. I don't think it's going to have any impact on the warming. The real concern is releasing radioactivity into the ocean, which ultimately gets into fish and shellfish and so forth. Now it's very low level radioactivity, but nevertheless, there's a lot of concern, you know, among the people of Japan. But it looks like they're going to go forward on that. Will that impact us here? I don't believe it will. I expect at some point there will be detectable levels of radioactivity here that are slightly above the background that would be able to be traceable back to Fukushima. I think that's possible. But in terms of that radioactivity, you know, causing a problem for us here, I don't think that's the case. In terms of it causing a problem for global warming, not really a concern there. But I'm glad you bring this question up, because this brings up the question of nuclear power. You know, where does nuclear power fall on the spectrum of solving the global warming problem? If you think about it, you know, nuclear power, you know, is carbon free. Once you build a plant, you've got, you know, 30 or 40 years of operation there. It's going to be pretty much, you know, essentially carbon free, produces a lot of power. So why don't we just adopt that as a solution? Well, I've been pretty negative on nuclear power for a long time, but it's a more complicated issue. I want to take a minute to talk about it. All of the nuclear power plants that are currently in operation are called second generation power plants, and there are, or almost all of them, there are a handful of so-called third generation plants, and they're basically just slightly sort of incremental improvement over the second generation plants. Well, the second and third generation plants, the ones that are in operation now, have you know, four big problems. And the first is the possibility of catastrophic failure, like we saw in Fukushima, like we saw in Chernobyl, like we almost saw at 3 Mile Island, came really close. The second problem is the one that, you know, that Ron mentions, and that is, what do you do with the nuclear waste? The waste that comes out of second and third generation nuclear power plants from the uranium process lasts for thousands of years. What do you do with it? Well, for a long time in the US, the answer was going to be Yucca Mountain, which is this storage facility in Nevada, and it was designed to be able to store the waste for tens of thousands of years. And I personally think that probably would have been a good solution, but about the mid-2000s, that came to a grinding halt when the people of Nevada rose up and said, not in my backyard. And their congressional delegation was powerful enough to stop it. So it's been pretty much in a caretaker state ever since then. They haven't shut down Yucca Mountain, they haven't given up on it, but they're not doing any work there either. And there's no nuclear waste being put there. It's kind of in just limbo, remains in limbo. So that's the second problem. The third problem is, if you own a second or third generation nuclear power plant, you have a path to nuclear weapons. And that's a problem, you know, that's a problem. And in fact, twice in recent history, once in 1981 and once in 2007, the Israeli Air Force took out nuclear power plants. In 1981, it was in Iraq, and in 2007, it was in Syria. So if you have, you know, these nuclear power plants proliferating around the world, you're going to have people, potential adversaries blowing up each other's nuclear power plant, and that's not a good thing. And I'll just mention that, of course, that North Korea's nuclear weapons arsenal, which is, in the range of about 20 or 30 Hiroshima class weapons, was produced by their nuclear power plant, reprocessing of the plutonium from the nuclear power plant. So those are three big problems. And then finally, the fourth problem is nuclear power is really expensive. It's the most expensive power on the grid. And that's partly because you have to deal with those first three issues I mentioned. So based on all that, I've been really negative on nuclear power, but I've opened my thinking up a little bit recently, and that is because there are now, at least on the drawing board, a number of so-called fourth generation power plants. There's about a half a dozen designs. There are even a couple of small test reactors that have been built. China has announced plans to actually field an operational fourth generation nuclear power plant by the end of this decade. The fourth generation plants significantly mitigate the problems I just mentioned. I'm not going to say they eliminate them, but I do believe they significantly mitigate them. And some of them are based on thorium cycle rather than uranium cycle, and they reduce the problem of nuclear waste, make it more difficult for nuclear weapons proliferation. But again, I don't think they eliminate all of these problems, but at least they do mitigate them. I have a lot of respect for Project Drawdown, drawdown.org. I think they're the leading organization on proposing solutions to the climate crisis. And they've identified about 80 solutions, mainly technology solutions. And they do have nuclear power in there. But they don't consider it a long-term solution. They consider it an interim solution. And so, I think I agree with that, particularly if we can move to these fourth generation designs that are inherently safer than the existing nuclear power plants. Yeah.
Jen Emery.
Is it possible that China could more rapidly adopt carbon-free forms of emission, maybe of generation, maybe not entirely enough to avoid having carbon fission, fusion, carbon emitting technology with coal. Could we induce them through maybe cash incentives or something of that sort, or is it just such a huge amount of new energy they need that you just can't build the carbon-free technologies?
Yeah, I think our ability to influence China is pretty limited. I am, yeah, I don't know if you guys ever watched the Panetta lecture series, but there was a really good Panetta lecture that took place on Monday on national security, and it had John Bolton and Admiral Mike Mullen, who's former chairman of the Joint Chiefs of Staff, and Michelle Flournoy, and it was all about geopolitics and the challenges we faced. And pretty much across the board, they said China is our biggest threat. And they asked Admiral Mullen, who I have a great deal of respect for, and he said, hey, Secretary Panetta, and what's the biggest threat out there? And he said, China, China, China. So our ability to influence China, I think, is pretty limited. I believe China is committed to going to green energy. For one thing, they're making a lot of money off it. Most of the solar panels you're going to buy are built in China. They're really going great guns at that. And there's a big region in central China that they're really bringing on the wind power, rapidly. They're bringing on solar rapidly. I think they want to go that way, but ultimately, it's just like Jim said, they're so energy hungry. They just need to bring on power as fast as they can to increase the standard of living of their people and keep their factories going and build up more factories and all of that. That I think our ability to constrain them is pretty limited.
Thank you,
Ron.
To get back to nuclear energy for a minute, when one country destroys the nuclear plant of another, what happens to all the fissionable material that was in the plant?
That's a great question. It just gets scattered. It gets scattered to the wind, and you've got a radiation problem. Plutonium is one of the most dangerous materials in the world in terms of, never mind a nuclear explosion, but if you just inhale small, you know, grain of plutonium is going to kill you. You know, it's pretty bad. So yeah, that's a bad thing. That's why I worry about if there was, many nuclear power plants built all around the world and people worried about weapons proliferation, that you would see more activity like as happened, in Syria and Iraq. And I can tell you, there's two paths to there's two paths to an atomic bomb. There's the plutonium path and there's the uranium path. And the North Koreans have taken the plutonium path, and that is the way you're able to go from a nuclear power plant, and then you reprocess the spent fuel rods from that into weapons grade plutonium, and that's how they built out their arsenal. Iran, on the other hand, is taking the uranium route, and the way the uranium route works is you mine uranium, then you have to concentrate the uranium-235, and you do that through these centrifuges, which you've heard about, these centrifuge arrays and all that. Well, why did they take that route rather than the plutonium route? Well, the reason is you can take these centrifuges, you can put them underground, you can put them in a under a mountain where the Israeli Air Force can't destroy them. On the other hand, a nuclear power plant, you can't do that because you got to keep it cool. You got to at least have the cooling part of it exposed to air attack. And that's exactly why they went the uranium route, because they want to be able to go down that path and presumably ultimately get to a nuclear weapon without Israel being able to stop them.
Dave Epple, you're muted.
Mike, I'm curious at your assessment of new technologies for carbon sequestration or for generation, particularly that one, but also biomass, and also about battery development. Ways to increase clean energy or to get rid of CO2.
Yeah, great questions there. Great points. Let me jump in on the battery part first. It's exciting to know that right here at Moss Landing, we now have the world's largest battery energy storage system. I'm not sure if many people know that, but it is the world's largest battery energy storage system at Moss Landing, and it's operational. It is on the grid. And it's actually, right now, it's 1,200 megawatt hours of storage capacity, and going to 1,600 megawatt hours of storage capacity, and it is plugged into the grid. So what's that all about? Well, it turns out California leads the country in solar, by far. We have so much solar energy that's being generated in California. In fact, one of the world's largest solar plants is not that far from it. It's called Topaz, and it's right down in San Luis Obispo County. It's 9 square miles of solar panels. 9 square miles. It's one of the world's largest, if not the world's largest, solar plant. But the thing about solar is you generate a lot during the day and you don't generate any at night. So what do you do with that electricity? In fact, in California, the way it works is we have excess power during the day by a wide margin, more power than we can use during the day, because of the fact that we have all this solar. So what do we do with it? Well, we have to ship it off to other states. And guess what? Not only do we ship it off to other states during the middle of the day, we actually have to, in some instances during the summer when it's really sunny, we actually have to pay states to take it off our hands. We pay them to take our electricity. It's hard to believe that, but a guy from PG&E told me that's true. Well, the idea of the battery energy storage stuff is to store that energy during the day and then play it back at night. And that's what the plant at Moss Landing is all about. And hopefully more and more of these will spring up. In terms of battery technology, it's getting better and better. The battery technology at Moss Landing is not the same as you would have in your car. It's designed, it's like, I think it's lead acid style, as opposed to the lithium-ion batteries that are typically in cars. But there is a project starting out there with PG&E, in addition to what I just mentioned, that's out there, and that will involve lithium-ion batteries. So that's all very exciting. As far as carbon capture and storage, I think where that's going to really end up playing a major role is going to be in conjunction with industrial production, particularly cement and steel production. As you probably know, cement and steel production inherently produce a lot of CO2 into the atmosphere. partly because they require a lot of energy, and of course most energy is done by burning of fossil fuels. But even if you had green energy powering the steel plant or the cement plant, there would still be a large emission of CO2, and that's because, in the case of cement, there's a step in the process where you're heating limestone, and that just inherently gives off CO2 into the atmosphere. In the case of steel, you're heating and you're melting iron ore along with coke, which is a form of carbon, and that just naturally puts CO2 into the atmosphere. Now we're still going to need cement and steel in the future, so I think what you're going to see is that carbon sequestration and storage, and also carbon sequestration and utilization technology being applied mainly at these industrial production plants, so we can keep down the emissions while we're still able to build out steel and cement. There was a law passed a few years ago. It's called the Future Act, and it put a lot of infrastructure in place for carbon capture and sequestration, and it was passed with strong bipartisan support. And the reason was there was something in there for the oil industry, and the part that was in there for the oil industry was the idea was you're going to capture this carbon dioxide at these plants. You're going to be able to send it around the country, this pipeline infrastructure, and then you're going to be able to use that carbon, take that carbon and pump it down into the ground, into these partially depleted oil reservoirs. And that's good, you're putting the carbon dioxide into the ground. But from the oil company's perspective, that was going to actually force more oil out through the wells. So it was a way to increase production. So, not such a great thing.
It just said, when you mentioned about the heat for steel, there's a recent paper in Science on new glass technology that they put some chemically modified so it can be done almost at room temperature.
Wow.
So
yeah, great.
I don't know that example.
That's a great example. There's a lot of new technologies coming along. And by the way, Bill Gates has a book out. It's called How to Avoid a Climate Disaster or something like that. And it just came out within the last month, and it's very good. He's a techno geek, but he's also a very practical person. And if you read that book, he talks about a lot of new technologies that are coming along, but he also approaches it from a very, pragmatic investor, businessman kind of perspective. He talks about the green premium, how much more you have to pay to bring on green technologies and try to get that green premium down. There's a lot of new technologies coming along that can help. I strongly recommend that book. It's good.
Yeah. Jim.
Mike, you haven't talked about the second largest country in the world, India. They've been a laggard, haven't they? Where do they stand?
Well, you're right. They're third. If you look at total emissions, it's China, U.S., India. And to tell you the truth, I haven't heard much about where they stand. I think they are, actively participating in the climate accord, and they're kind of in the same situation as China, in the sense that they need to bring on more energy to increase the standard of living of their people. So probably a similar kind of situation.
David Barish, you're muted.
This group is all, believers in climate change. Have you ever had an opportunity to speak to a group of skeptics?
Well, when I speak to a large group, there's usually 2 or 3 skeptics in the audience. They're usually outnumbered by a large amount. But yeah, it's fun to talk to them. I've actually got, I've given, well, you saw the talk that I gave to League of Women Voters, but I've also given other talks that specifically aims to debunk the most common climate change denier myths. I have backup slides, and whenever I go to a presentation, I always have a ton of backup slides I can get to very quickly to address any kind of issue that people bring up. And I kind of prioritize them, and I always used to prioritize as the most common myth. It's not happening. That was the mantra for many years. People just said, well, it's just not happening. Look, it cooled down last year. It's not happening. Don't bother me. But I think people are kind of getting away from that. And now they're kind of along, I think the next most common one is, well, it's happening, but it's not caused by us. It's just some kind of natural change happening. It's the sun or something like that. And of course, I've got tons of slides to just prove all of that. The good news is the country is coming along. If you look at the trends in terms of polling, 20 years ago, people who understood that climate change was happening and humans were causing it as a problem was down probably in the 40% range. Now it's up in the low, even mid 60% range. I'm sure there's an upper bound. I think it's probably about 70%. But, being up in the 60% range is pretty good. And certainly our leaders are starting to come around. When you get the people to understand it, then eventually our leaders come around as well. And so I think that's all good.
Fred, and muted.
Yeah, it seems to me beyond the problem of skeptics or deniers is the problem of individuals realizing that we have a responsibility for the stewardship of this planet beyond our lifetimes and even the lifetimes of our children. And I think it's hard for people to comprehend that. Is, you ask me, if this is the way they perceive it, you ask me to make these sacrifices now, and I'll never realize the benefit of it. And I think that's to me, the real difficulty in moving us towards dealing with this problem. Is people just don't see it affecting their personal lives.
That's absolutely very well said, Fred. That's absolutely true. I sometimes I end my talk by saying, there are three questions we need to ask ourselves. Number one, do we care about the fate of people in the world who are less fortunate than us? People living in third world countries. Number two, do we care about the fate of future generations? And just exactly what you're talking about, generation, not just our children, our grandchildren, but the people who are going to be alive in the next century and the century after that. Do we care about what those people and those future generations are going to think about us when they look back and say, you people back in the 21st century had a chance to solve this problem when it was solvable and you didn't do it, and look what you gave to us now. So I hope that the answer to all of those three questions is yes. But you're quite right. It's something that's in the future. There are two big problems in terms of public perception on climate change. Number one, it happens slowly. Like I said before, really, if you're looking at climate change, you need to be looking at a record that's 30 years or longer. 50 years or longer would be better. Well, 50 years is a pretty big chunk of a person's adult life, and it's kind of hard to think back 50 years and, look at this change over 50 years. And a lot of people kind of see the world based on their own perceptions and their own personal life, as opposed to some data, some chart that I stand up here and show you on PowerPoint. And the other thing is exactly what you said. It's really, the real problems are in the future. We're going to be long gone, and it'll be our grandchildren and our children's children and so forth. Come back to Leon Panetta. He often talks about, the American dream and the concept that each generation tries to make it so their children will have a better life than they did, and that's how things progress. And we've kind of gotten to the point, I've been reading that the millennial generation is the first generation that won't have things as good as their parents because, economic stressors and hard to find a job and all those kinds of things. And, that's kind of a turning point in many ways. And climate change is just going to make it worse because, it's going to put more stress on the world. And we have to be, everyone has to make a personal decision. Do I care about the future generations? Do I care about these kids that are going to be in the future? Or am I just worried about, how well is my stock portfolio doing and what kind of a car am I going to buy?
Lois and then Jim. And
just to say that there was a Native American belief, we have not inherited the world from our ancestors. We have borrowed our children.
That's a great statement. That's a wonderful statement. I'm going to
remember. The Native Americans, before we were ever here, had that. And of course, we clobbered them. And yes, now we're continuing to clobber the earth.
Yes, and when I see, when we fail to take action on climate change, it saddles our children, grandchildren, great-grandchildren with more action they're going to have to take and more pain they're going to have to sustain to settle things down. So, that's a big issue. And by the way, this is a good time to mention something which I kind of back on the science again. And not many people know this, and that is, we talk about sea level rise. The Earth is warming and the sea level is rising, and the long-term sea level rise is actually going to be the biggest issue. Right now, we're not that focused on it. We're more so focused on things like severe weather and wildfires and things like that. But in the long term, into the next century and beyond, sea level rise is going to be the big problem. And the reason is, and this is something that not many people know, is that there is a long, long time lag between warming Earth and rising sea level. So, for example, let's say we are able to stabilize the warming Earth at, say, 2.5 degrees above pre-industrial, which my prediction by the year 2100. So we stabilize the temperature. Here's the problem: the sea level is going to keep on rising. It's just going to keep on rising, and in fact, it's going to keep on rising for many centuries, maybe 500 to 1,000 years. Why is that? Well, it's because it takes that long for the ice sheets, the Greenland ice sheet and the Antarctic ice sheet, to come into balance and to come into equilibrium with the warming Earth. Another way of saying it is it takes that long for all the ice that's going to melt to actually melt. So what does that mean? Well, let's say, we are able to stabilize the temperature by the year 2100 at whatever level. The people who are living in the next century are going to have to start bringing the temperature of the Earth back down, or they're going to have to deal with a rising sea level that's going to go to tens of meters, not just 1 meter, not just 2 meters, but 10 meters, maybe 20 meters over several centuries. That means you're basically abandoning all the major cities of the world, pretty much all the major cities of the world, and moving inland. And an open question is, maybe you can do that over 500 years, but I don't know. It seems like it would be a lot of stress. I think what's going to happen is the people alive in the next century are going to conclude we've got to cool the Earth back down, or otherwise we're going to be dealing with this continually rising sea level, and it's just inundating our major cities. And here's the big problem with trying to cool the Earth back down. It turns out that about 95% of the heat of global warming has actually gone into the ocean. Now, you can thank the ocean for that, because if it wasn't for that, we would no longer be alive. The Earth would have warmed so much, the air and the land would have warmed so much. If it wasn't for the ocean, moderating that major swaths of the face of the Earth would no longer be inhabitable, and there would have been a huge die out of humans. So that's the good news. The good news is 95% of the heat has gone to the oceans. The bad news is when future generations conclude they have to cool the Earth back down, all that heat is going to come back out. There's a lot of heat there, and it's going to start coming back out, and that's going to make it slow going to cool the Earth back down. All the while, they're going to be dealing with rising sea level.
Jim.
When you listen to Biden official talk about the infrastructure investment, they keep saying jobs, jobs, jobs. They're trying to sell that on the basis of present economic benefits to justify the big expense. Is there validity in that argument, do you think?
I think there is. Certainly, it is a political strategy, and it is a good political strategy. I think if it gets to the point where Biden is indeed able to show that these green investments are leading to new jobs, particularly blue-collar jobs, particularly in traditionally Republican swing states, then I think he will achieve an unstoppable momentum, which I think I'm pretty sure that's his political strategy. I think that's good. Other groups, independent of President Biden, have looked at this and said yes. For example, Project Drawdown says this could be one of the biggest, job transformation and job creating events in history, going all the way back, like to FDR and the New Deal, that kind of thing. So I think the answer is yes. I mean, there's people are going to have to be retrained and find maybe upgrade their skills and so forth. But yes, I think I think there is some validity validity to that. By the way, what do we need to do in terms of infrastructure? Well, the first thing we need to do is we really need to build out the power grid. The power grid as it exists right now needs to be, the capacity needs to be increased by at least a factor of 2, if not a factor of 3. We've got to increase the capacity of the power grid by a factor of about 2 to 3, because we're going to be electrifying everything we possibly can. At the same time, we've got to start bringing on green energy, wind and solar, at about 3 to 5 times faster than we're bringing on now. We've got to really start bringing on that green energy even faster than it's going on pretty fast right now. We've got to make the power grid more robust. We've got to really make the transition in terms of transportation to electric vehicles, and of course that's moving along that direction. By the way, California has, by law, is to decarbonize our power grid by 2045. So that's law. We've got to completely decarbonize the grid, and we're making progress on that. According to what guy from PG&E told me, we don't have any coal-fired plants in California. We currently have no coal-fired or petroleum-fired power plants in California. We have only natural gas-fired plants, and we have only one nuclear power plant left. That's Diablo Canyon, and it's going to be taken out of commission in a few years.
David Barish, and then Fred. Mary. David, you're muted.
Is there any possibility, has anybody given any thought to the possibility of using a warming ocean as an energy source?
Great question. That was a big topic back when I came out of graduate school back in the 70s. It's called Otec, Ocean Thermal Energy Conversion. And there actually was a demonstration Otec plant built in Hawaii. And the idea there is when you have a temperature difference between the upper ocean and the lower ocean, that can drive a cycle. Whenever you have it's kind of the same way that geothermal energy works, but you're doing it in the ocean from the warmer surface layers to the colder subsurface layers. And Hawaii was a perfect place to demonstrate that. But there's a lot of challenges with that. Whenever you're putting something out in the ocean and trying to bring power ashore, whether it's a wind turbine or an ocean thermal energy plant, that becomes a pretty expensive proposition. And I will mention that although it was a hot topic, 30 or 40 years ago, I can't point to any, operational or significantly operational Otec plants now. And in terms of the 80 solutions that Project Drawdown talks about, and they do talk about ocean energy solutions. They talk about wave energy, for example. Otec is not part of that. Geothermal is. Even geothermal is pretty limited because you need the right geological structure. Iceland is really big in geothermal because they've got it there. You don't have to drill down very far and you're hitting all kinds of hot water. There's some geothermal energy in California. Heat pump technology is good. And I think you're going to see in the future, you're going to see homes just, at least in the right climates, naturally being built with heat pumps as being part of that, rooftop solar being part of that, heavy insulation being part of new home technology.
Fred, and then Mary.
I can't tell you that Otec has been a big player. It just hasn't been.
Fred, and then Mary.
I was just thinking we really part of this discussion is considering the expenditure that governments are willing to make in order to deal with a changing environment. And then I think about Highway 1 in Big Sur. When we continue to pump money into repairing that roadway against the inevitable is that roadway is eventually going to disappear and can't be rebuilt. And yet we continue to, without hesitation, pump millions of dollars into shoring it up. And I don't think anybody believes that it won't happen again in the very near future. And how long?
I'll go you one better on that. And that is the city of New Orleans. It cost, tens of billions of dollars to rebuild New Orleans after Hurricane Katrina. And ultimately, New Orleans is not going to be salvageable. At some point, we're walking away from New Orleans, and it may happen in the next 20 years. I think one more direct hit from a Cat 5 hurricane on New Orleans, and people are going to conclude it's not worth the $30 billion to rebuild it because it's just going to happen again. And in fact, it's going to happen more frequently. And in fact, if you look at the long-term projections, by the end of this century, New Orleans becomes an island surrounded by a levee, with the Gulf of Mexico around it. And it's just not sustainable. And it's tough to make those kind of decisions, but you're quite right, Fred. At some point, we have to make those kind of decisions.
Mary.
This group just finished reading Matt Ridley's The Rational Optimist, and he, of course, thinks that all these problems will be solved by human technology. And and we obviously do see that things have, there are a lot of plans and things working. Just I wondered whether you think there's any credence to that. And but I saw something just recently about a plan to shadow the earth, an umbrella or something to protect us from the sun. How's that going to fly?
Yeah. Well, let me take the first part. I haven't read the Ridley book. Jim did describe much of it to me. What I will say is I tend to be an optimist, as is Bill Gates. I'm kind of in the same level of optimism as Bill Gates, and that is, this is a problem that can be solved. And it can be solved with technology, but it requires a lot of political will to do so. It requires a lot of investment. It requires people all pulling together, not just in the United States, but all around the world. So I am optimistic that the problem can be solved. It's a tough problem, and we need to get going on it, and we need to accelerate our efforts there. But I believe, and I'm not. And there are other people who aren't as optimistic. I have colleagues, scientific colleagues, who say no. You're being overly optimistic. It's actually much worse than you think it is. But I'm on the same wavelength as Bill Gates. And if you read his book, you'll kind of get a feeling for, what his viewpoint is on how the technology can get us to where we need to be. You mentioned the shading of the earth. That falls under the category of geoengineering. There's a broad category of solutions called geoengineering. The idea is you're making, kind of changes to the earth. My general position on geoengineering is the research should go forward, but I'm not optimistic anything of it is really going to come from it. The two big problems with geoengineering solutions are, number one, unintended consequences. And the sun shading thing you're talking about is a great example. What they're talking about there is injecting up into the stratosphere microparticles that would reflect the sunlight. Now, in fact, there's solid science on that, because in fact, when we have a volcanic eruption and volcanic ash gets thrown up into the stratosphere, lasts for a long time, it does cool the earth. There's no doubt about that. There was the famous Krakatoa volcano, which put a huge amount of ash into the stratosphere, and that was followed by the year with no summer. All around the world there was no summer because there was so much ash up there, was reflecting the sun away. And it really cooled the earth. So there is truth in the fact that if you put particulate matter up there, aerosols, they indeed will reflect solar radiation away and can have a significant cooling effect. The problem is, number one is unintended consequences. And the unintended consequences, eventually that stuff comes down. And when it comes down, we breathe it. So what are the health effects of breathing, those particles? That's a big concern. And the other concern is the cost of doing that, and what it would take to actually put enough material up there. I'm not in any way advocating doing that. And there are other solutions that are kind of similar like that. There are solutions about, well, we can make the clouds wider. We can seed clouds with salt crystals, particularly the low stratus clouds we have off California. We can develop these autonomous unmanned vehicles that would sail across the ocean and see these clouds from below with salt particles. We can turn them a little bit wider, and that will reflect a little more sun away. I think it's fine for the research to go forward on those, but I'm not optimistic any of them are going to really be a big player here. But there is one big concern I have, and that big concern is people should not think that there's a silver bullet out there, that there's some type of geoengineering solution that's going to come forward and it's going to solve our problems, so we don't have to worry about it now, keep on burning fossil fuels. I don't believe there's going to be any such silver bullet. And I'm happy to see the research going forward, and maybe something will come of it. But I'm pretty darn certain there's not going to be any silver bullet out there.
Dave Apple.
Mike, I watched your the video that Jim sent around, and I liked your thoughts on criterions, just how to handle them. But my concern is that 4 years from now, 2 years from now, the legislature could change, the government could change, and we'd be back in an anti-climate change presidency. And I'm just wondering, how do you change these contrarians? My view of it is that people become, there was all this negative stuff in the media, probably from et cetera, and people believe it, and as you said, it's very hard to change a contrarian view, even if the oil companies would work on climate change. Do you have any thoughts on how you shift this? Or
I might just add that we have a contrarian in our group who is not here today very significantly, which just lacks
bothersome.
Yeah. Yeah, that's the toughest question anyone's asked today. That's a tough question because it's really symptomatic of, it's not just the climate problem, but it's really gets to the core of the divisiveness that exists in our country. And it is huge. And there's huge amount of divisiveness in the media. Everyone has the option now of going to their own world and own their own worldview. They can find the media outlet that will feed them exactly the worldview they want to see, and they can stay in that echo chamber, and you're never going to reach them. You're never going to change their mind. So that's a huge problem. I wish I had the solution to it. If I had the solution to it, I would, our democracy would be much better off, because our country is more divided than it's been since the Civil War, quite frankly, and there are a lot of amplifying things that are making it worse. One of which is internet and social media. Social media is contributing to the divisiveness. The internet is contributing to the divisiveness. The fact that we have cable TV and talk radio, we no longer have a Walter Cronkite. Everybody believes their own person they want to believe and reject everything else. And climate gets wrapped up right in that. There's no doubt about it. In terms of political leadership, I can't overemphasize how important it is to have in the White House a person who understands this problem and pursues it. If we end up 4 years from now electing someone who is a climate denier and takes us back in that direction, that will be an absolute disaster, because it percolates down from there. It percolates down from there, and all the way down through government. And it kind of, I used to work in government. I know how it goes. It kind of percolates down from the top. So it's just really crucial.
It percolates all over the world. That's the problem. The U.S. is viewed as a model.
That's exactly right. The world looks to the United States to lead on pretty much every issue, and they certainly look to us to lead on this issue. And indeed, we should be leading. We are, the second largest emitter, right now in time. But if you look back historically from the beginning of the Industrial Revolution to the current time, and look at the cumulative emissions, you find that we are number one. The United States has put more CO2 and other greenhouse gases into the atmosphere, since the beginning of the Industrial Revolution than any other country, more than China, twice as much as China. So we are the world's largest offender. We should be the world's leader. We're the world's richest country. We should be able to lead on this. And the fact that we abrogated that leadership for the past 4 years has been really devastating. And other countries look and see us not leading, and they say, well, gosh, if they're not going to do it, we're not going to do it either.
Yeah. Marlene, you're muted.
Mike, have you had occasion to speak with any of the naysayers in Congress?
I have not. I have spoken quite a bit with Jimmy Panetta, and he, by the way, is a great leader on this. There's one of the tools in the toolbox is called carbon pricing, and that's the idea. You put a fee on carbon at the pump, and then or sorry, not at the pump, but at the wellhead, and then you give everyone a dividend back, such that you reward people who are low users of carbon intensive fuels or fossil fuels, and people who are relatively high users of fossil fuels end up paying more than they get back in dividend. There's about a dozen carbon pricing bills going forward in Congress right now. Jimmy Panetta had, I think, the second or third one, and I personally think his is the best. I think it's really good. He is a strong leader on this. He's a member of the Climate Solutions Caucus. He really gets it. He understands it, and he's all the time trying to reach across the aisle and form coalitions and move forward. So he's the only member of Congress I've talked to about this, and he's a very receptive audience. And he is, I can't applaud him more on this.
I think it's interesting. I just read that Biden is talking about tax credits for people who get vaccines, and
Wow.
I think honestly, people who are skeptical about these things can be addressed in different ways, and one of them is through the pocketbook. And so, as the cost of electric cars goes down, and there are all these rebates, I think you're seeing more and more of them because there's a real incentive for people to try. But I did have a question about, some people are saying about batteries. I won't buy an electric car because the battery is gonna, go into some dump somewhere, and it's worse for the environment than fossil fuels. And so, there's that trade-off. I think we saw the electric power one as our power gets cleaner. So when people say, well, you're burning coal to charge up your car, we don't have that anymore. But you do have this thing about the batteries.
Well, that's true. That's true. I mean, but we're always going to have issues of recycling materials. We have issues of recycling, everything. I think it's being addressed, but there's two sides of every issue, and there's a carbon footprint to build anything, and there's a carbon footprint to recycle anything. Recycling, though, is important, and that's a big part of the solutions here. But the battery storage is important. And in fact, Bill Gates actually talks about not only that, we talk about nighttime, daytime storage, which is what Moss Landing is all about, but he even talks about in the long term, we need to develop long-term battery storage to go from winter to summer. So we're saving up all the energy in, say, Minnesota in the summertime, and we're playing it back in the wintertime. We're going to even be going in that direction. So batteries are going to be out there. But there's other ways to store energy. And this is a fun thing to talk about. One thing, and there's actually a number of places where this is done in the world. You're trying to store energy from, daytime to nighttime, or from one season to the next. Well, if you live near, a dam and a lake, what you can do is actually use, when you have an excess of solar energy, you can actually run a pump and pump the water up the side of the mountain to the reservoir. And then when it's time to, when you have a dearth of solar energy, then you actually let that water come down through the dam and run the turbines. So you're actually using, in that sense, you're using the water to store the energy rather than a battery. The other thing fun to talk about is, there are these concentrated solar energy plants. There's two types of solar energy. Photovoltaic, that's the part we're familiar with, that's rooftop solar cells. But there's also concentrated solar energy, and there's a big plant down. It's called the Tonopah plant. It's down in Southern California, and it's off. I'm not sure if it's I-10 or one of the highways there. I've driven by it a couple of times, and it's a big array of mirrors, and there's a central facility, and those mirrors are constantly turning, and they're concentrating the sunlight on this central facility. And in there, there is molten salt, and it's heated to like 1,000 degrees from this sun being concentrated. This technology only works in the desert pretty much, and you need a large area for it. But the neat thing about it is, when the sun goes down, it keeps on generating power. It doesn't stop. And the reason is because all the energy is stored in that molten salt. And it's hot enough that it lasts all through the night, and you're still driving the turbines all through the night. The next day the sun comes back up and you heat it back up again. So that way you're maintaining the cycle throughout the day without actually using a battery. You're storing the energy in molten salt. So there are ideas like that, other ways to store the energy for long term.
Ron.
Some people have converted shipping containers into small homes. Would it be feasible to use batteries as building blocks?
Possibly, maybe the shell of the batteries. I guess the real concern of the batteries is what's inside them. The lithium ion or the lead acid, and what do you do with that? And I'm pretty confident we'll develop technologies to handle that. And we may have to have landfills. We have landfills now. And we'll work through that. But ultimately, electrification is the way to go. We need to get away from burning of fossil fuels. We need to get to electrification. And by the way, what about airplanes? What are we going to do about airplanes? Are we going to have electric airplanes flying from here, take off from San Francisco and fly to London on an electric airplane? Well, no, that's never going to happen. But I wouldn't be at all surprised within 10 or 20 years that when you get on a plane in Monterey to fly to San Francisco, or Monterey to fly to, on a commuter flight to fly down to LA, that you're going to be on an electric plane. There are electric planes now that they're starting to be ramped up to be on the scale of commuter flights. I think the goal is a plane will carry 100 people for 100 miles based on lithium ion batteries on the plane. So that's commuter flights. What about the flight from San Francisco to London? Are we always going to have to fly on a plane that's using jet fuel and putting carbon into the atmosphere? The answer is no. There's another fuel, it's liquid hydrogen. In terms of planes, you really have to talk about energy density. And the energy density of jet fuel is about 43 megajoules per kilogram. Energy density of lithium ion battery is about 1 megajoule per kilogram. So it's 43 times less, dense than jet fuel. But the energy density of liquid hydrogen, the same liquid hydrogen that fuels rockets and the space shuttle, is about 120 megajoules per kilogram. So it's about 3 times, that's about 3 times the energy of jet fuel. Now, does that mean your jet plane in the future is going to take off like the space shuttle? You're going to be like an astronaut or a rocket? No, it's not going to be anything like that. It'll be just like a regular plane. The engines will actually be very similar to existing jet engines. The designs will be a little bit different. They'll be really wide-bodied planes because the fuel will be stored, inboard as opposed to in the wings, because it has to be kept cold. There'll be new infrastructure required at the airport to keep the liquid hydrogen cold. If your flight gets canceled and late in the afternoon, it's going to fly next morning, well, they're going to unload all the fuel off the plane, just like they do on the space shuttle. But ultimately, we're going to get there. Certainly by latter part of this century, we're going to have jet planes that are going to fly around the world based on liquid hydrogen that will be produced from green energy. You'll have green energy electrolyzing water into hydrogen and oxygen, and you'll liquefy that, and you'll have clean jet fuel.
If the plane crashes, don't you essentially have a bomb?
Well, you have a bomb now anyway. You have a bomb. Plane crashes with jet fuel. That's true. It'll be about the same.
Not a Hindenburg.
Not a Hindenburg.
Any other questions? I guess we're about out of our time. I have just a housekeeping question. Is there a way to access your channel to see this presentation and other ones?
Yes, I'll put this on my YouTube channel, and I'll send you. How about if I send you the link, Marcia, and you can
Sure.
forward it around to everyone. It's publicly available. You can even find my YouTube channel you could probably just Google Mike Clancy Climate, and it'll take you there.
Okay.
And I'll try to get this up, in a few days. By the way, is there a formal name for this group, or is it just the book club?
Yeah.
Carmel Foundation Book Club, I think, nonfiction book club.
Yeah, it's nonfiction book club of the Carmel Foundation.
Okay, Carmel Foundation Nonfiction Book Club.
Yes.
Okay, great.
Mike, I want to thank you. You fully lived up, as you always do, to my high expectation. It was
Exceeded expectations.
Yeah,
Thanks, Mike.
that's wonderful.
Thanks so much. I really appreciate
Thank
it. Thank you, Marcia. Thank you, Jim. Thanks everyone for coming. And
It was great. And again, I apologize for the technical difficulties.
no problem. We got through it and
We made it work.
Thank you.
take care.
thanks a lot.
Thanks so
Thank you.
much.
See you later.
See ya.
Bye-bye.
Bye.